And I think we will move to our next part of our workshop. It's the project talk session, ongoing projects under Fresh Eyes on CMIP. And each project will be presented by a team member or colleague of the project, either live or through a pre-recorded video. So let's get started. And our first project will be introduced by Dr. Luo, and who works at the Center for Climate Research Singapore, and she is also the colleague of this project. And Fei, please go ahead.
Welcome, everyone. My name is Fei Luo. I'm a research scientist at Center for Climate Research Singapore, CCRS. And today I'll be presenting a Fresh Eye on CMIP project that's supporting the CMIP 7 data requests. And as a climate scientist, most of us must have gone through this experience of as a student, you started using the CMIP outputs and use that data for your term papers or analysis and learn how to analyze large data sets. Then as you go through your career pathways, you started to maybe even produce the CMIP data as a modeler. And now you can also get involved and be part of the CMIP consortium or teams. So this is very exciting opportunity for me to present and be part of the project. So next slide, please. So you can just give everything, yeah. And so for the CMIP 7 data request, it is a really humongous effort that involves multiple stakeholders and communities. For example, we start with the MIPS, the model intercomparison projects and communities. They are the people of communities. They define their priorities and what they want to study. For example, in the figure, if you want to have research on the carbon cycle or coupled with atmosphere and land, then you want to request for a set of data sets that can be used for your analysis and research purposes. And then we're back in the modeling centers around the world to produce the data that we want and need by giving them or proposing a list of variables. But how to make this happen? This is coordinated by the data request task team, the photo below, coordinated by CMIP. So this ensures the effort that is more efficient, and we're all talking, everybody's voice is heard, especially for CMIP 7 phase, that global south and the represented teams are also very emphasized in this process. Next slide, please. And we all also ask ourselves this question every time when a new CMIP comes. Then we say, what's the difference? Compared to the last one, why are we doing this, right? So it's also like the IPCC report, the same. Then I can tell a little bit about the differences between CMIP 6 versus CMIP 7 data request. So during the CMIP 6 last cycle, all the data request is more focused or centered on the variables. So we have list of variables, you define your variables and you want this variable output. And then all the modeling centers have to go through this process called summarization, because different models have different model architectures, and ensure the comparability between the different models. We need to make sure and standardize all the output so that everybody can just go to the same platform and download different models, but still be, counting on the liability of those variables. But for CMIP 7, this is a different approach. It's not centered around variables anymore, but rather something called opportunity. So this is not, it's more than just a variable. And the reason we are centered around the opportunity, which I will talk a little bit more on what an opportunity is later, is that this ensures to minimize the redundancy and ensure the consistency and efficiencies in the data request. Because of course, almost everyone wanted to have a near surface temperature and also humidity or precipitation, right? So instead of we are producing too much or like overlap in this way, we can minimize the redundancy and also make the whole process more, how to say, easier and more intuitive for people to comprehend, to use later. Okay, next slide, please. So for CMIP 7, we also have a new structure for the data request. So in the data request, we mainly have three subsets or subgroups per se. So the core subset is the all-purpose set of variables suitable for production in all MIPS. Basically, it's a baseline variables that about 130 of them. Then the harmonized ones is on top of the core variables that we coordinate as all 13s. We coordinate between different things and try to harmonize between the different things of pins so that we know what we want based on the need, and we justify if it's okay and how to make this whole thing consistent. And unharmonized one would be more independent and not in the mainstream. And harmonized one was also aimed for the LR7 fast track deadlines. So next one, please. So speaking of the opportunities, what is an opportunity? It is actually the intended use case or justification for one or multiple variable groups. It contains that experiment groups, and with the information, it could be in different experiment requesting this one versus also this variable group can be just one variable or more than one variables. Then we identify them as groups and we group them together, and we also map back to this opportunity because we need to justify why we're requesting this. And if it's, for example, if this is like how to say, realistic, that for example, if you're requesting the output temperature on all model level, I think it occupies a lot of effort and also storage, and it's not too realistic for all the modeling centers. Okay, next one, please. And this was the data request timeline, and everybody involved in this for almost a whole year effort. That during this effort, we're also very proud that we incorporated the stakeholder engagement that through three different phases, like consult, like openly available public drop-in sessions, consultation phases, and we also sent out the questionnaires to all the modeling centers and drop-in sessions where everyone can have their ideas and opinions heard. Next slide, please. So this is a typical, for example, this is what we are working on, right? So I'm also author in the author team for atmosphere theme for the data request. So as authors, we are asked to answer the following questions. For example, to do the variable selection, like what data is required, and including those CF metadata. So, and why it is needed and why it's a priority, because we also need to set if a priority high, low, medium, and who will make use of it and how it will be used. So we need to have this forward thinking to already think about our stakeholder and users of the CMIP data that we're producing later. And for example, let's take opportunity clouds, radiation, and precipitation as an example. I will not go into details, but you can see from slides that there is a description, detailed description, or and also justification on why this opportunity is needed and what the expected impacts. And next slide, please. And associated with this opportunity, you can also see the on the very left side, you can see this opportunity is belong to which variable groups and for what time slides you need this opportunity. And then in the middle column, it tells you which experiments or maybe groups need these variables or opportunities. And on the right column, it's the actual variable, for example, D task mean or D near surface temperature, maximum, and precipitation, etc. So next slide, please. So for our supporting as a fresh eyes on CMIP project, It was established last year in March as an initiative by Timothy, and each Fresh Eyes group member is assigned to author team, and then we're responsible for supporting different author groups and also get involved in the thematic papers, and we meet once 1 or 2 months to contribute to identify the parts we can contribute. Next slide, please. So moving forward, for example, this is the description of our project. That if anyone is interested, you can go to the link that Douglas shared in the very beginning. And basically, the latest event activity we had was to review the thematic papers prepared by the author team. So, and feedback on everybody can get involved and have their opinions and ideas heard on the paper. And it's very essential, I think, for early career scientists to get involved in such process. Next slide, please. Yeah, so those are the project objectives, and then the next slide is just the group of our current groups. So yeah, that's all I think from my side. If you are interested in, this is the whole all the people involved in this project. I think next slide, the last slide, please. Yes, so it's a big thank you for Timothy for the initiatives, and he's a co-chair. And now we're welcome Robert as also our co-chair. So if you're interested in our project, please get in touch with us. Thank you. Any questions?
Yeah, you can raise your hand or just leave the question in the tablet or in the chat. Let me check if there are any questions. Oh, yeah, Timothy. Oh, okay, no, Timothy. Yeah, maybe I think the time is limited, so maybe we can stop here and we move to our next project. And our next project will be a combined effort by 2 projects. And first we will watch a short video from Dr. Wandi, and who works at Lawrence Livermore National Library in US. Then it will be followed by a live introduction from Dominik Stiller, who are working at the University of Washington in US. So let's begin with the video.
Good morning, good afternoon, and good evening, everyone. My name is Wandi Yu, and it's my great pleasure to represent our team to give an overview of the CMIP 6 Plus and the CMIP 7 Person Dataset Evaluation Project. Before I begin, I want to thank all the group members who have contributed their time and efforts to this project. And if after listening to this talk, you're interested in joining us, please feel free to reach out to me or Camila. We are still welcoming new members. So forcing drives climate change and variability, and getting forcing right underpins climate change attribution and the future projection utility. Here are examples from past CMIP phases that highlight how important forcing is. In CMIP 3, models that didn't include volcanic forcing showed ocean heat content warming trends that were 2 to 4 times higher than observed. In CMIP 5, once stratospheric aerosol corrections were applied, model simulations line up much better with observed early 21st century warming. And in CMIP 6, an underestimation of the SO2 emission reductions over China led to major discrepancies in the modeled aerosol optical depth trends across Asia. So the takeaway here is forcing matters and matters a lot. Within the Fresh Eye in CMIP, there are currently 2 projects related to forcing. One is this one focused on evaluating CMIP 7 modern forcing dataset. And the other looks at the consistency between the paleo and the modern forcing and its implication for CMIP 7 experiments. Danny will introduce this project in the Europe and Africa session later. So in this project, our goal is to assist the forcing test team by carefully evaluating the latest datasets and providing the constructive feedback. To that, we laid out a 2-year plan. The first stage started this March and will run through next June. The stage is all about evaluation, analyzing the data, and writing a comprehensive report. We have CMIP 6 Plus in our name, but that was available before CMIP 7 was finalized. Now the CMIP 7 data are available. CMIP 7 will be our preliminary focus moving forward. So ideally, we hope to publish papers for each of the forcing components we evaluate by working with the forcing test team. And these papers will be cited in the final report. But we also understand that people are busy and not all findings will lead to publications. So our minimum goal is to deliver a detailed and scientifically grounded report. If there are any errors significant, we will report it to the test team. For example, our group member Chris Wells identified some negative values in the earlier CMIP 6 Plus dataset. He reported them to the test team, and those issues has been fixed in CMIP 7. Then this report will be shared with the forcing test team to support future data development, and with the modeling centers to help clarify any questions that arise when using the forcing data. We have been running monthly meetings that are organized like informal seminars. This brings together our team members and the forcing test team to share their relevant past works, and we are planning to share the updates in the future. Inside our larger group, we have set up smaller working groups focusing on a specific forcing dataset, each led by a leader as a coordinator. These smaller groups handle the bulk of analysis and writing, and our group members also signed up for the internal reviewers to each chapter to make sure the science is solid. Again, if this work interests you, whether doing the analysis or reviewing, we would love to have you on board. Then starting in March of next year, we plan to move to stage 2. The phase will focus on building a software pipeline to support the future forcing data evaluation. We will build it on the code developed on stage 1. We will share code across the working groups and design a unified open tech pipeline. Here is our proposed timeline as a reference. We are planning to start writing the report in September and have the first draft of the report ready by December. Then we will start the reviewing process, which is targeted to be finished by March, and we will have the final report in June. The coding pipeline is targeted to be finalized in October next year and be published by the end of next year. Next, we will briefly share some preliminary results. First is from the greenhouse gas group, and the figures were created by Chris Wells. In this figure, this is the timeline of the percentage of changes in greenhouse gases concentrations from CMIP 6 to CMIP 7. And those red lines are for CO2, methane, and N2O. The changes are quite small, so small that they are barely distinguishable in this plot. Then Chris applied these concentrations into the phyl-R radiative model. Here, the small differences in the concentration were translated into a very large changes in the radiative forcing because of how sensitive the climate system is to these gases. Next, we will hear from the volcanic forcing working group, and Dominik will take over from here. Thank you again for your attention, and please do not hesitate to reach out if you would like to get involved. Thank you.
Yeah, Dominik, over to you. That's great.
Hi, everyone. Yeah, so Wendy already gave a good introduction about what our forcing evaluation group is doing, and I'll be talking specifically about the stratospheric aerosols or the volcanic forcing for the historical experiments. This forcing data set was created by Thomas Aubrey at the University of Exeter, and the evaluation was done by Mei Chim, Dominik Stiller, which is me, and Elisa Ziegler. So the stratospheric volcanic aerosol dataset comes in two variants. One is the emission dataset and one is an aerosol optical property dataset. The emission dataset is basically a list of volcano eruptions, each with its own like sulfur dioxide mass, injection height, injection time, and location. And this emission dataset consists of two parts that are stitched together. So post 1979, we're using a satellite dataset. And before that, the emissions are derived from bipolar ice cores. So if you have ice cores in Greenland and Antarctica, you can pinpoint the latitude of eruption. And this emission dataset requires climate models to have interactive aerosol chemistry and microphysics, which a lot of climate models actually don't have. So that's why Thomas Aubry also provides an optical properties dataset, which uses a simple emulator that emulates the transport of the volcanic emissions and then the subsequent chemistry and microphysics. And this emulator is called EVAH and is used to create the pre-satellite optical property dataset, and 1979 and later, the GLOSAC, the satellite-derived dataset, is used. So we can look at the difference between CMIP 7 and CMIP 6 now. So here we're looking at the optical depth. So basically how much of the visible incoming sunlight is reflected or absorbed by the aerosols. And the first thing that's noticeable is that the CMIP 7 dataset actually extends back to 1750, which allows us to run extended historical simulations, while CMIP 6 ended or started in 1850. And CMIP 6 also has fewer eruptions, actually. So CMIP 6 in red here between 1930 and 1960 actually had a volcanic hiatus, while CMIP 7 has some smaller magnitude eruptions here. We can also look at the difference between these global mean aerosol optical depth lines, which is shown at the top here. And below, we show the same difference between CMIP 7 and CMIP 6, but latitudinally resolved. We can also see that in the late 19th century, there's actually a lot more eruptions in CMIP 7 now, which will lead to a cooler climate there. The timing of the eruption plume has also changed, or the shape. For example, for the 1883 Krakatoa eruption or the 1963 Agung eruption, and some eruptions like this one here and this one in 1980 have a reduced magnitude, actually. We can also see that CMIP 7 actually has a systematically lower aerosol optical depth in recent decades compared to CMIP 6, which is due to a new background aerosol climatology. So these background aerosols, they're not associated to big eruptions. They come from either small eruptions or from continuous outgassing of aerosols and their precursors. And those might be transported from the troposphere via the tropopause into the stratosphere and need to be considered for the stratospheric aerosol optical depth too. So this climatology that is used for these background aerosols comes from the satellite dataset and is the average over the 1998 over 2002 period, which was volcanically quiescent. So there's no big eruptions to contaminate the signal. And there's a seasonal cycle to this climatology because of seasonal variations in the atmospheric circulation, which gives rise to this peak of aerosols in the northern hemisphere in May and a peak in the southern hemisphere in October. Apart from the optical depth, we can also look at the optical properties, such as the effective radius. And the effective radius also changed quite a bit between CMIP 7 and CMIP 6, which leads to different radiative properties of the aerosols. And similarly, the surface area density and volume density have also changed and have this like shift in baseline here. And this is important because the volcanic data set is also actually used to derive the ozone forcing data set by running interactive simulations for a couple of models with the volcanic forcing and then taking the ozone as ozone forcing data set for other models. Finally, we can also look at the climate impact of the volcanic forcing. So here we're looking at anomalies of the global mean surface temperature derived using a reduced complexity model. In blue, we see the CMIP 6 forcing, and in red, we see the CMIP 7 volcanic forcing. And here, it really shows that the increased amount of eruptions in the late 19th century really leads to cooler late 19th century. But then 1950 and onwards, the CMIP 7 volcanic forcing actually leads to a warmer climate. So in recent decades, the CMIP 7 forcing is actually 0.1 Celsius warmer than CMIP 6, which has implications for the tuning of models and their evaluation. So to conclude, there's a new volcanic forcing dataset for CMIP 7. It comes in an emission variant and an optical properties variant. And compared to the last generation of volcanic forcing, there were changes to the magnitude of eruptions and the latitudinal plume structure. They added small eruptions that weren't previously captured. They changed the background aerosol climatology, and the optical properties were recalibrated. And all of this leads to a historical simulation that's 0.1 Celsius warmer in CMIP 7 compared to CMIP 6. So I'd be happy to take any questions now if you have any. You can also email us later. So the first three, that's the evaluation team. Thomas Aubrey, he's the creator of the forcing dataset. And if you want to learn more about the dataset, you can also look at the forcing documentation through this QR code here. Thanks.
Yeah, thank you, Dominik. I think we can still have one or two questions if anyone have. You can raise your hand or leave the question at the outlet. If not, maybe we will move to our next project. Okay. Thank you, Timothy. Sorry. Thank you, Dominik. I will move to our next project, which will be introduced by me. And this project is about the model bias. Let me share my screen. Okay. Yeah, so this model bias project it's led by Sabrine, Pauline, Andrew, and Brody, and Fossey. I'm really happy I can present this project because I'm also a member of this team. So, and I think Brody will present this project at Americas Hub. And I really appreciate all the work of these colleagues. They really helped us and keep this project growing up. And our name of our project is Identifying and Communicating Model Bias. As the title suggests, this project focuses on two main challenges in climate modeling. One is identifying the most important model bias that exist in CMIP models. And second is communicating those biases clearly and accessibly, especially for researchers who rely on CMIP output for like impact studies or for the decision makers. And we know that the models become more and more advanced, and they also can be more and more complex. That makes the bias may shift, but they rarely disappear. So that's why it's important we not only to check them, but also to make sure they're understood and communicated across our community. So here is a quick look of our outline. And today I will introduce the project goals and accepted products. Then I will walk through what we are doing right now, including a list of priority biases. And I will show some specific example in depth, like the ocean heat content bias. And finally, I will tell you about our future plan and how you can get involved. And for our project goals, in short, we are trying to do two things. Like I said, identify important model bias, and second, communicate early to our scientific community. So for the identification sides, what kind of model biases exist across ocean, land, atmosphere, and the Earth system as a whole? It's they are trying to do. And then we try to group them and figure out which ones are the most critical. And second part is we try and find the sources of these biases, like where they actually come from, and whether it's due to like the missing process or parameter tuning, or they are because of the operational gaps. And in the future, we can be what we can be done to reduce these biases. We basically will get these ideas from the literatures and from the model development teams. And another thing we're trying to do is the model, the bias communication methods, because we also want to highlight the indicators people use to trace the biases and understand which one really matter the most for climate perception and impacts. Then come to the communication part. We want to make this information useful not only for the model developers, but also for people who using CMIP data and in the applied areas and for the modeling impacts or the police decision maker. And for the duration and anticipate projects, our project is 18 months duration, and I think we still got 1 year left. So our main project, main anticipation will be like a review paper on model bias, and we try to make some contribution to the shape tools like the rapid evaluation framework, which is also part of CMIP 7. And of course, we will also keep sharing our work through talks and community events like today. And here is another thing we want to mention. It's about the earlier Fresh Eyes work, which is our project based on. It's a community survey led by Frosty and Andija. And they try to find out what early career research is ranked the most important diagnostics and the most commonly used analysis method and the areas where diagnostics are missing. And that work helped us to define what kind of model bias matter most to CMIP data users and across all Earth system components. So that's lead to what we are doing right now. Right now, we have gone through relevant literature and the community feedback and our own experience, and we identified 28 model biases that seems to be especially important across CMIP models. And we have grouped them into 5 main areas. One is the ocean and sea ice, including things like ENSO behavior, sea surface temperature, ocean heat content, and AMOC, and so on. And the second part is the land and land ice. It covers the variables like snow cover, runoff, soil, and vegetation properties. And for the atmosphere part, such as the annual cycle, energy flux, and the WITCZ, climate variability model modes, and energy flux, all these things. And fourth part is Earth system. Here, like the equilibrium climate sensitivity and transient climate response, and also the historical climate change are all the variables we are grouping in this area. And finally, the impacts and adaptation. We look at how the model bias affect the climate drivers for fire and temperature variability, and even the large scale circulation patterns like the Ross Bay waves. And right now we are reviewing all the studies across these areas to understand what is causing these biases and how severe they are and what already been done, try to address them. And we are still need more people for all these areas. And here I will show an example we are doing. It's the ocean heat content. As you all know, the ocean heat content is critical because it tells us how much the heat the ocean is storing, and therefore how it buffers the climate change. But in CMIP 6, there are some persistent bias. For instance, here is a paper we reviewed. There are some models show a warm and fresh Arctic at depths, which is not realistic. So others tend, and we also find that there are other works about the ocean heat content show that the CMIP model underestimates the ocean warming trend since the 1970s. And one of the reasons is the biased up ocean mixing, especially in the tropic. That will lead to the incorrect heat flux and the sea surface temperature. But based on what we are reviewing, we find that the good news is that improving mixing parameterization in these regions would help to reduce these biases. And this is the kind of analysis we are aiming to do for each major bias we just mentioned about in our list. We try to combine the scientific understanding and with actionable ideas for the future. And for the future plan of our project, we are finally trying to do is develop a bias documentation or paper, and it's what we are doing right now. And we also want to support tools like the rapid evaluation framework so that the model bias are easier to find and check and to compare across CMIP 7 models. But we cannot do it alone. We would love your help. And as I mentioned before, we have 5 areas, but we are still looking for some specific expertise, including the snow cover processes and the cloud-reliable correlations, and like internal variability in precipitations and temperature. So if you ever worked with a tricky model bias, or you have spotted anyone that seems not talked about, and we would love to hear from you. And this is a very much open and collaborative effort. So this is a quick overview of our work we are doing right now about our project. And we think this kind of project is very important to make CMIP 7 more transparent and more useful and more robust for the community. And thank you. And I'm happy to take any questions and comments. So if you have any questions or comments, just raise your hand or leave it in the chat. And if not, maybe we can move to our next project. Our next project will be introduced through the video, which is recorded by Dr. James Paul, who is one of the colleagues of this project. And you can leave the question in the Padlet, and he will answer the question later. So let's begin.
Hello, my name is James Pope, and along with Lena Teckentrup, I am a co-lead of the entry-level documentation for SRI's project. You can also see underneath the list of group members who have contributed brilliantly to developing this project over the last sort of 10 months or so as part of Fresh Eyes on CMIP. So a big thanks to all of them for their continuing support. Since joining Fresh Eyes, Lena and I were also members of the CMIP 7 documentation task team. We lovingly called this the grown-up group, as we started out as the Fresh Eyes documentation subgroup, and we needed a way to differentiate which documentation group we were talking about, so we called them the grown-ups. However, we discovered in our meetings with this task team that even though we had a really broad and wide-ranging experience of CMIP data and climate model information between us, we often were confused and bemused about what different terms were being talked about and what they meant and why users had to make sure they were part of a minimum viable documentation. So if we were left floundering, how would newcomers to CMIP data cope, particularly early career researchers and those we were thinking it's a lot about people disconnected from the National Meteorological Centres and the university institutions and like who run and produce these climate models. If you're not directly linked into them, how are you going to find out what any or all of this information means? And, you know, you can't go wrong with a meme. So here's the meme around this, you know, because CMIP is powerful, it allows you to explore future climate change. But there isn't really guidance for new users at the moment. So that's what we are wanting to achieve. You know, that's why we think we need an entry-level documentation. And so from this, our proposed Fresh Eyes project was born. We had an early rebrand. We were going to use the naming around that very popular set of books. They're bright yellow and they say some topic like parenting or quantum mechanics for dummies, and we were going to do CMIP for dummies. But we rebranded entry-level documentation to sound a bit more serious, sensible, and also to make sure it sort of worked across a whole range of different countries. We started to scope out what this entry-level documentation would look like, taking inspiration for something that I had produced before for users of the UK climate projections here in the UK, produced by the Met Office. And this is what we have. This is the starting point. You get given a website and you're able to access this interactive PDF. And it's hosted online so that UKCP users have questions, and it's designed in a way that you can dip into your preferred section. So I might want to learn more about accessing UKCP data, the headline findings and key results. And when I click on the link here, which you can see a little blurb about the section is underneath, I get taken into that section of the document. I can go back home, or I can click next using these key tabs. And then it takes me into the information I need as I click next. And you can see here, I've got my page on the key results spreadsheet. It's got other links to underpinning information around the information that's been provided. So I can go and learn about our probabilistic projections or our marine projections. It also helps me understand the different emission scenarios and regions, again, by just flicking to different parts of the presentation. Or I can just work through the section step by step, or go back to the start of the section, or go back home using the guidance buttons at the top. Or you can just work linearly through the guide from beginning to end. So you could just start with option 1, the philosophy around UKCP, and then understanding which information you want to use, to the different data accessing options in sections 3 to 6, or section 7, which guides you to some future learning. And you could just work your way through from 1 to 2 to 3. And as you work through this, particularly through the accessing the data, the levels get more technical, more complicated as you go. So the headline findings is a Word document you can read as a PDF. Option 6 is about downloading NetCDF outputs, but it allows your user to guide their way through. Now, I could build this based on years of engagement with UKCP users, exposures to the questions they had about the data sets, and also by observing and resolving common pitfalls of colleagues within and outside of the Met Office working with these data sets. They would come to me with their questions, or they would talk about the issues they were having, and I could provide solutions. And based on that, those years of learning, I was able to sort of bring it all together into this one piece of documentation with supporting links and providing the information that people needed. So that gave us an idea of a starting point. But how can we replicate this for such a broader global community of CMIP users? I was able to focus on this because it was just a small set of tools, a limited number of options, and mostly just UK-based users. CMIP is global. It's massive. It's orders of magnitude bigger than UKCP is. So what we had to do is we have to go and find out. Because we had this idea in hand. We had a destination. We had no idea how we're going to get there. What is our user need? Why do they need it? And what are they going to do with it? And these 3 questions are really important to helping us understand actually what we're going to produce and what we're going to include in it. Because without the answer to these questions, we cannot build our entry-level documentation. We'd just be making what we think is right, not what our users need and is actually right. We had to find the common ground that we could all start from. And then we could build an ELD that would stop us from falling apart. Because although we're all spread out and the world may be between us, if we do not stay together, then there's so much that will be left undone from our climate research. And as it was conference season, we said, what about conferences and a survey? We wanted to start meeting people face to face and finding out their challenges. We first gave this a go at AGU back in the last December 2024. You can see here Lena and Kelvin presenting the poster. And although we got the jungle theme, because it's Christmas, we have got some little Christmas tweaks and Easter eggs in there. You can see on the right, the wish list, all I want from CMIP is you. But we wanted it to be a very engaging poster. Last month, we were in Vienna for EGU 2025. And next month, we'll be at the ESA Living Planet Symposium, which is also in Vienna. You just see here the poster updated for Easter themes. So we've now got bunnies instead of Santa hats and some actual Easter eggs. And we've got Susanna and Lena here presenting our poster during EGU. And you can see if you look at this poster is we've got some information for our users on the left. The who are we, why are we doing it, information about Fresh Eyes. Then we asked some sort of very broad questions. Do you ever, and just left them sort of hanging there, a bit of a primer, getting people engaging. And then we just wanted people to know they weren't alone, that other people have these issues. Stuck on some pens, stuck on some post-it notes, and we just asked people to leave information for us. Put their answers on the board, let us know what their issues are. We also have a link to the survey, which I'll be touching on in a minute. So that poster format, as I've just talked through, the introductory information and getting people to leave those comments and post-it notes, then links to our survey. And this is our survey. This gives you a quick screenshot about what we're looking. A really big part of the survey is trying to understand, as well as what people need, how long have they been using CMIP data for? Because we welcome views from anyone in this survey. You could have been using CMIP data for decades. You could never have touched it. All of your views matter for helping us shape the information for entry-level documentation. And we are trying to spread this survey as far and as wide as possible. It really is anyone who wants to or has used CMIP data can make an impact by engaging on our survey, and we would love you to be part of that. We want to really canvass that broader range of users, especially those who are unable to attend conferences such as EGU. They're great conferences, they're big, they allow lots and lots of people to be there, but they're also a bit of a barrier. They're long, difficult for people with caring responsibilities, parents, things like that, but also just the financial element of traveling to a big city like Vienna, having a week's attendance at the conference, a week's accommodation, food, all those things, they can be quite limiting. So we wanted to make sure that there was no reason why nobody couldn't let us know what they needed in our entry-level documentation. It's this huge range of questions, and we really want to try and explore the needs of the user through our questions. That's our goal, that's our aim. We've had some really good initial feedback so far, and already we're getting some really useful nuggets. Some of it, already on our list, things we knew we'd have to have. What are the experiment IDs, RIP codes, explaining some of the acronyms within CMIP. What is the fast track? Why is it called the deck? All those sorts of the basics that even then can feel like sort of gateways you've got to try and break through before you can get into CMIP data. Some stuff was out of our scope. People asking if data can be made available on cloud servers. I mean, obviously great ideas, great thinking, but more of a data access question than an entry-level documentation question. Of course, should information being made on those sorts of cloud servers, then entry-level documentation needs to cover how you access that information, how you work with it. So it's never going to be an entirely finished project. It always has to be a bit of a living document. We've also had some great suggestions that made us think about where the answers are, how we would communicate them, and whether or not we might need to go and write some pretty complicated answers to make sure people can have the information they need. So what's next? Where next? Next up, obviously, ESA Living Planet Symposium, which is in June 2025. Susanna will be taking an updated version of the poster, fewer Easter eggs and bunnies. I'm not sure what our June theme would be. Maybe midsummer, maybe something about a solstice, being as it's around about the 21st of June, the conference. We'll then close the survey and start to sketch out the documentation, and we'll start to develop our tool, our product. And we hope to have a beta test of this sort of in the mid to late autumn, October, November of this year, something for people to start using, feeding back on. What have we missed? What's too complicated? What's superfluous and probably not needed? These things are never going to be right first time. We will need to do that. But for now, and I'll finish by thanking you for your time. Thank you for listening to this presentation. And I'd love it if you would complete the survey and share the survey and make sure as many people as possible are engaging with the survey, because the more responses we have, the better our entry-level documentation will be. And it really can only be great if it's got all you folks involved, no matter where you are in the world, no matter where you are in your career, no matter what you're actually going to study with it. Every single one of you can make a big impact on our entry-level documentation by scanning this QR code that's here up on your screen now. I'll leave this slide up, and I'd just like to once again thank Lena and the rest of the group for all the hard work that they've done so far. And I look forward to us sharing an entry-level documentation beta test with the Fresh Eyes community and even wider later this year. Enjoy the rest of the workshop, and thank you very much.
Okay, and that's the GEMS project. So if you have any question, you can leave your question in the Padlet, and definitely he will join this workshop later. And when he sees the question, he will answer it in the Padlet. So, and I think this is our full project, and thank you all to our presenters for sharing these exciting initiatives. And if you are interested in getting involved in any of these projects, please feel free to reach out to the project colleagues or leads. You will find the email and website just in the chat, which Laura sent. You can find the project information from our CMIP website and from the Fresh Eyes website. And I think this is the 2 sessions of this morning. So I think we will move to our next session